Hello again, everyone. Thank you so much for joining us today. During the first workshop that you organized, we feel really honored to be hosting Usha, so that who's will animate a workshop about exploration of data using Python. So you are happy about starting this new chapter in Tunisia, and so you are part of the PyLadies Global organization. So you present a network of Python users, and so you are a woman who love programming with Python. This is our team. I'm Munir Bilaid, so basically I'm engineering statistics and data analysis, and so I'm recently working as a business intelligence consultant at Prime Analytics. Amal Lili also, she's an engineer in statistics and data analysis, and she's working as a data science engineer in DNA analytics. Hidyat Nani also, so she's a postdoctoral fellow at the Pasteur Institute of Tunis. Yes, Amal, this is your turn.
Hello, everyone. Thank you very much for joining us today. PyLadies is a global group that was created to involve more women in the Python open source community. PyLadies was founded in 2011, with the first chapter being established in Los Angeles in April of that year. We are a group of women developers who love the Python programming language. We write code by day or night. We all just like writing Python code, and that's what brings us together. There are 76 chapters identified across 29 countries. The number of chapters has been always increased along the year. So our mission is to promote, educate, and advance a diverse Python community through outreach, education, conferences, events, and social gatherings. PyLadies also aims to provide a friendly support network for women and a bridge to the larger Python world. Anyone with an interest in Python is encouraged to participate. Women make up the majority of the group, but membership is not limited to women, and the group is open to helping people who identify as other gender identities as well. Now I will be pleased to pass to Hedia.
Before we start the recording, we want to let you know that actually we already started the recording. So please, if you don't want to see yourself, switch off the camera, because actually we will post this video in our YouTube channel. And if you want to see your face, okay, switch on the camera. But we want to record you also that it's better to switch off your camera because of the internet issues that we have sometimes. Other point is, if you have any question, you can raise your hand. So please go down, you will see that there are reactions. So if you have any question, so you can use the reactions in Zoom or leave a message in the chat box. We want this session to be as interactive as possible and to ask as many questions as you want. Please feel free to ask questions. And then we want to show you our plan for our next meetups. So this is the first meetup we have about exploratory data analysis using Python. Then our next meetup will be about building GitHub apps using Python and GitHub library. We are looking also for our third part, which will be about building Python Flask application. And then our plan is also to organize a workshop about how to build your very first Python package. And then the last part is how to integrate R in Python and Python in R. So thank you for joining us. Please subscribe to our YouTube channel. Don't forget to subscribe. And thank you very much. Here we show we are actually on social media, on Twitter, Facebook, LinkedIn. We have our GitHub, our YouTube channel, Meetup. And follow us, learn with us, and please enjoy our session. Thank you.
So let me just introduce our dear trainer today. Usha, hello everyone. Sorry, yes. Usha Rengaraju is ranked as top data scientist in India for the year 2020 by Analytics India magazine. She organized NeuroAI, which is India's first ever research symposium in the interface of neuroscience and data science. So she's also a strong advocate of neurodiversity and organized India's first ever conference in neurodiversity in December 2020. That's so wonderful. So she specialized in probabilistic graphical models, machine learning, and deep learning. And so she's also the Adjunct Faculty at IIT Madras for the master's program in data science. So I'm sure that you will learn so much from her today. Enjoy the workshop. And so the floor is yours, Usha.
Yeah, hello. Am I audible?
Yes.
Yeah, I'll share my screen 1 minute. So my screen is visible now. Yeah. So is everyone able to see my screen?
Yes.
Yeah, thank you. So I thank the leadership team of PyLadies Tunis, Hidia, Mauna, and Amal, all three of you for inviting me for this session. It's my honor and privilege to be part of this session. There's a lot of effort which has gone into organizing this event, and I'm very happy with the way you have designed the next 5 events as well. I'm sure it's going to be wonderful. Please join the meetup group so you'll be automatically notified of those events. Go and join the individual events. Go on RSVP for the individual events and don't miss out on it. And also follow them on all social media handles like Twitter, LinkedIn, so you'll be notified of all their future events and everything what they are doing. And with that, I'll get started with today's session. So today's session is going to be on exploratory data analysis using Python. I'm going to use one library called Plotly, and we'll be using a bit of Matplotlib and Seaborn as well now and here and there at small places, but majorly it's going to be Plotly. Why Plotly and not Matplotlib and Seaborn? Seaborn is very good. You have got nice visualization charts and all that, and it has got good visualization interface as well. But Plotly is used for interactive visualization. Seaborn is more of static one, and you will not be able to build interactive visualizations using Seaborn. But with Plotly, you can do a lot of interactive visualization. So the major library which I'm going to use is Plotly, and a little bit of Matplotlib and Seaborn here and there. And we'll also be seeing Chloriplet's maps as well. And so the use case which I've taken today, so everything of today's session is going to be in a single doc. So, this doc, anything which I want to share in future also, the references and everything will be there in a single doc. It will be useful for you to not to miss out on any references. So I've shared this at the beginning of the session. I'll share it once again for the benefit of the people who have joined late as well. Give me a minute. So for people who have joined late, I'm sharing the link once again. I've shared it in the chat window. Please check. And so this one document contains all the links. So you can follow me on Kaggle here. And then you can also, the notebook which we are going to use in today's demonstration is the second link. The second link is a notebook which we are going to use in today's demonstration. And there is outside this, I've also shared another notebook of mine. If you want to explore Seaborn and Matplotlib, I've just takeaway notebook. I've just prepared one. After the session, you can dig through this notebook. And if you want to follow it in Colab, then the same notebook which we are going to use today, I've put it on Colab for you. But you will not be able to run it unless and until you upload the data set to the Colab. And that's it. So the resources are there in the first few lines, the resources which we're going to use today. And so the second link, which is this one, is going to be today's session. The main notebook is going to be here. So let's get started with the main notebook. So what this use case is about? So I've taken a real world use case for today, instead of just going through the Plotly, I've taken a real world use case and I'm going to walk you through the real world use case. This was a Kaggle competition which was launched sometime back, maybe 2-3 years back. And I'm going to walk you through that use case. We're going to explore the data of that real world competition. It is the data science for good competition organized by an organization called Kiva. So Kiva crowdfunding is a not-for-profit organization. So no, not it's not not-for-profit. It's an online crowdfunding platform, and it's particularly inclined towards helping the poor people who don't have enough resources to make a living. So they give loans to those people. So for them, the priority is to identify the poorest of poor people who, with a little amount of funding and the support will be able to form their own business and get started. So their main priority is to help the people who are below the poverty line and, help them get started. So in order to do this, they have to identify the people who are very poor. So that is their main intention. So this is the data set which has been given. And the problem statement is you will have to use machine learning to come up with, you can use external data sets as well. And you'll have to use machine learning models to come up with, a model which will be able to identify the poor people in a given demographics. And this particular competition has got some data which is being given by the host organization itself. But for this competition, when it was launched 3 years back, the host had told, in order to build this model, you can also use external data sets. But for the purpose of today's session, we are only going to explore the data set which is given by the host. So the host has given us 4 data sets, all CSV file. And the first file is Kiva loan CSV file. And we also have Kiva MPI regions location CSV file, loan theme IDs, loan themes by region. And these are the CSV files which we have. We are going to explore this data using these CSV files. And so let's get started. So this is the problem statement and the context. Now let's dive into the code. So this block of code, if you want to follow along and if you want to execute it along with me, what I would recommend is this is the notebook. So what you should do is you should go to the notebook. When you click on this notebook, you will have an option 3 dot. Just go and fork, create a new copy or create a copy. Fork, you'll have an option to fork. The first option will be an option to fork. Since I've already forked it, it's showing as edit my copy. But when you're forking it for the first time, you'll have an option to fork. So once you fork it, you will get, you'll be getting it in the this mode where you can start executing the cell. And this particular cell, I'm just placing my thing. I'm just running it. It will run. So this is how you'll have to fork a notebook and start running it. Is anyone in this class getting stuck in how to open a notebook and how to fork it and execute a cell? Is anyone stuck and you need help or something? You can put it in the chat window. Is everyone up to here? Is everyone able to fork the notebook and start executing
Yes, for me, yes.
it? Yes. So then, if anyone is stuck, I'll share the notebook link once again, direct notebook link once again, so you can just fork it and start running it. So when you start running it, you will actually be able to, connect to the use case more than me running it and then you just seeing it. So you can start running it on your own as well.
You should
So,
also, yeah, they should also have an account on Kaggle, right? Kaggle.
yeah, you should have an account in Kaggle. To create an account in Kaggle, what I would recommend is if you have a Gmail account, then you can just quickly create it in a minute. Just log in using your Gmail and it will be created in a minute. And the other fields, just give it as empty now for now. And then later after the session, you can go and build your complete Kaggle profile. So go to kaggle.com and quickly create an account in gmail.com if you want to fork the notebook, and just don't fill in all the details and all for account creation. Just click the next and just create the account now, and then later after the session you can go and complete the complete account completion. Yeah, I think my system is a bit slow. Can one of you put the notebook direct notebook link in the chat window so that people don't end up searching for where the notebook is?
Yes, I will do it. Don't worry.
So yeah, we're all set. So everyone who has an account is able to fork it, and are up to here is what is my assumption. Now let's get started with the code walkthrough. So we have seen what the problem statement is. We have seen the context, and we have also saw we have 4 CSV files which is given to us by the host itself, and we are going to explore it. And for exploring, we are using the basic packages. We have NumPy, we have Pandas, we have Matplotlib, Seaborn. So Seaborn, I have already mentioned. You see, Matplotlib, Seaborn is built on top of Matplotlib. So Matplotlib, Seaborn is much more sophisticated, and it has got a lot of advanced visualization features, which you can which will give you more powerful capabilities for visualization compared to Matplotlib. And I'm going to use, in addition to these two libraries, I'm also going to use a library called Plotly. So I'm importing Plotly, and I'm also saying I want the Plotly graphs to be running within the notebook mode. And in Plotly, I have to import three things, three modules. One is Plotly offline, Plotly graph objects, Plotly tools. All three of these APIs are very important to come up with your interactive graphs. And the most important one is the plotly.graph.obj.js. This is the most important API, but the other Plotly graphs is also very important. And now, this part is about importing all the necessary files which you require, and giving an alias for it. And so the reason why you have an alias is because you don't have to, every time you want to use a particular function from numpy, you don't have to go type numpy fully. Instead, I'll put np and call the function name. Then you will have the CSV files. And now I'm just going and checking what all CSV files I have. I have the 4 CSV files: Kiva loans, Kiva MPI region locations, loan theme IDs, and loan themes by region. So these are the 4 CSV files which we are going to explore today. And now, in order to take a CSV file and convert it into a Pandas data frame, Pandas is a data manipulation library in Python, and it has several functions, very useful functions for manipulating the data set. And in order to make use of the functions, you'll have to first create the pandas data frame object. So in order to create a pandas data frame object for a CSV file, I'll use this function pd.read_csv, which will take CSV file as an input, and it will give me a pandas data frame object as the output. So this is the data frame object is the core building block of Pandas. The first step whenever you do anything with Pandas is to create a data frame object. And then you have data frame object comes with a lot of methods and utilities which you can use to manipulate your data set. So here I'm creating a Pandas data frame object. So I have 4 CSV files. For each of the CSV file, I'm going to create a Pandas data frame object. In Pandas, if you want to see the first 5 rows of the data set, you can use the method called head. And if you want to see the last 5 rows of the CSV file, you can use the method called tail. Dot head will give you the first 5 rows and dot tail will give you the last 5 rows. So now I've given dot head, I'm able to see the first 5 rows. I'm able to see in this Kiva underscore loan CSV, what are the features which are there. It has funded amount, loan amount, activity, sector, use and country underscore code, region. These are the features there, and I'm able to see the values for the first 5 features. So we have completed one CSV file. We can go and we can do this for the other CSV files as well. So we have completed Kiva loans, and we did the head as well. Now the same way I can go and I can take the Kiva underscore MPI regions underscore locations, and I can convert that CSV file into a Pandas data frame, and I can do a head on it. Similarly, I can go and do create a Pandas data frame for all the 4 CSV files which I have. My system is stuck. Give me a minute.
If you are talking, Usha, I can't hear you.
No, I'm not talking.
Okay. Okay.
My system is stuck. So just a minute, I'll just
No problem.
close few.
Take your time.
Yeah. Yeah. Now it's back. So I'm taking the second CSV file, and then I'm taking the CSV file and converting it into a Pandas data frame. Once I convert it into a Pandas data frame, I'm doing the head, and I'm just checking the first few rows. So this by doing this process, I'm able to.
Usha,
Nika?
you're
Am I
not
audible?
sharing your
Sorry?
screen. You're not sharing your screen.
Oh, okay. Yeah. So by doing this process, I'm able to quickly get a snapshot of the first few rows in all of the CSV files. And so this is what is, this will, by doing head and tail, I can just get a feel of what the features are and what kind of values each features does. So this is generally the first step when you do start with an exploratory data analysis. You see all the files which are there, and you just check out the feature names, columns, and then you see for the first few rows. This is something which you do initially. And then now that we've seen all this, let's go and start checking how many rows are there in the first data set we're going to explore is Kiva underscore loans CSV file. We have created a data frame for it, which is Kiva underscore loans underscore DF. We'll just go and see how many rows this data set has. So this data set has got 67,000, 6,71,205 rows. So you can just run it. And the next step we'll be seeing, we will be slicing. So somebody is entering the room. Is she admitted? Yeah. So we have around 67, 6,71,000 rows, and we have 20 columns. And out of this 20 columns, there is one particular column called country. So this country is what I'm going to slice. So in R also you will be having slicing operations where you'll use square brackets to filter out a particular column. So in Python also you can do slicing. Here also you will use square brackets only. Under the square brackets you will give the name of the column name which you want to slice. Here I'm going to slice country, so I'm giving the name of the column name in the square brackets. So this is not the only way to slice. You can also slice using the .loc and .iloc operators, where .iloc you can give the index of the field column name which you want to slice, and .loc you can give the name. But if you don't want to use .loc and .iloc, the simplest way to slice is just give the in the square bracket, just give the name of the column which you want to slice it out. So it has got 20 columns. Out of 20 columns, I'm interested only in countries. So I want the country wise total. In every country, how many loans are given? So that is the total which I want to know. This I can accomplish it using a very simple method called value underscore counts, which comes with Pandas data frame. So I can just slice out the country, and if I do a value underscore counts, it will give me every country how many loans are given, the total number of loans in every country. I don't want to see all the countries. I just want to see the top 5 countries which has the highest loans. In order to do it, I'll just again call the head method and put it as 5. So hope this is clear for you, how the slicing operation, and if you want to find counts, then you can all use value underscore counts method.
Yeah, that's clear. Thank
you. Yeah. So the next I'm going to, do some plotting now. And I also have another CSV file which has got all the country level details. So I'm going to show you some geographical maps also. And I'm going to show a particular map called Chloriplet map, where, instead of just seeing bar charts and histograms and all of it, see, this is about how many loans each country has. Instead of seeing, you have 2 options. You can see it as a bar chart, or you can also see it in a graph, because if you use a world map, and you can give darker shades of color for the countries with more loans, and for countries with less loans you can give a lighter shade of color. So you can either do it as bar graph, or you can do visualize it in a world map as well. So I'm going to show the second option, which is visualizing it in the world map. So I have a data frame, I sliced out the country, I've done the value counts. Now I'm going to put it in a world map. For that, the way Plotly works, you need to, before we get into the Plotly graphs, I'll give you a brief introduction about the Plotly graphs. So this Plotly, the way it is slightly little different from the Matplotlib and Seaborn, the way you write the code. So the Plotly, the main component is the figure. So you will be plotting this figure, and this figure component has 2 things, which is the data and which is the layout. Layout is all your decoration, axis points, x-axis, y-axis, and all this decoration comes out of the layout. I think you might have layout in R as well, some kind of equivalent for layout in R as well. So all this number of subplots, everything is governed in layout. The data is where you actually, the data has got something called trace components. What trace is, you can, whether you want a scatter plot, or if you want a bar plot, or if you want a whatever line plot, whatever it is, it will be as trace components. A single graph can have both bar plot and scatter plot. So if you, whenever you want, for each of these visualization component, you will be using one trace. So data has building blocks called traces, And traces is where you will actually use the visualization component, whether scatter plot or histogram or whatever that is. So these are the components in Plotly. I'll repeat again, figure is the most important component. Then you have data and then you have layout. The layout is where you have something called layout options, where you have all this decoration related thing like x-axis, y-axis, how many, what are the x-axis ticks are, what are the y-axis ticks are, whether you want legend, what is the font size you want, all this decoration layout related things, you will have it in layout options. And for the data, you can give several plot components like scatter plots or histograms, and each of these plot components is governed by the trace object. So this is the chart or the components of the Plotly. Now let's get started. Now that you know the components, now let's go back and draw a simple graph. So the first line is I'm taking my slicing out the country, doing a value counts, and then storing it in a data frame, which is con underscore df. And this con underscore df has got two columns. One is the country name, and the other thing is a count, which is actually the total number of loans each country has. And then I'm just resetting the index and dropping off the index. And this is my pre-processing. And then I'm drawing my data. This is my data. I told you the data is one of the most important thing. So you have the data, and then there's a dictionary. I'm having inside my dictionary, I'm giving all the important fields. The first thing is I'm going to draw a chloropleth map. So the type will be the chloropleth map. And then I'm going to have country and country names. So the location will be the countries, and the location mode is the country names. And so in the country names, what am I going to plot? What is the feature which I'm going to plot? That is going to be the number of loads. And I'm also for the country name, the text. So when you hover over the country, you'll be able to see the country name. That I'll be using the text feature field attribute to mention that. And then you can give the color scales which you like, and the other fields which is related to the color scales, you can mention it, but these are optional parameters. If you want, you can mention it, or you can ignore it as well. The marker is for each data point, you're mentioning the color, the width, the type of data point, and all this is governed by the marker object. And if you want to have a color bar, and you can also mention the attributes of the color bar irrespective of what language, whatever language you're using, whether Python or R. I think these are components, visualization components, which are common across all the languages. This color bar and what are the how marker point should be, how a layout should be. I think these are components which you will also be working in R as well. It's just that this particular API has got different set of functions and methods and different feature names for it. So this is what I told you. The data is one of the important components. So in the data component, I'm mentioning what type of graph I want. It's a chloropleth map. Then I'm mentioning all the color related components. I'm giving some values, and then I'm mentioning the marker where I'm mentioning how each data point should look like. And I'm also having a color bar. I'm giving some attributes for the color bar and the layout. So the layout is going to be the title. I'm mentioning what is the title I want, and whether I should have a frame or not. So I'm saying I don't want a frame, then I'm giving this attribute as false. And whether I want coastlines. Coastlines is the country and the ocean is divided by the coastlines. Whether you want to show the coastlines in the world map or not. Yes, I want the coastlines. That's why I mentioned the parameter true. And there are different projection types, map types. So there are different variants of maps. You can use the map, whichever variant you like, or you can experiment and see different variants. You'll be able to find these details in the official documentation of Plotly. And so this is the layout component. This is the data component. I told you three components are important: figure, layout, and the data. We've seen the data and the layout. Then we'll have to go and add this data and layout to the figure, and then plot the figure. This is going to be the world map. So instead of just seeing it in a bar chart, I'm just able to hover over that country. I'm able to see United States. I'm also able to see the count 6093. I'm hovering over Mexico has 5741. India has got 11.237. And you can see hover over and see Kenya has got 75.825K. So you can hover over and see as well. You also have a color bar. This is called color bar. And so you have coastlines, strong coastlines dividing the ocean and the land, but you don't have any frames for this graph. So these are attributes, the layout options which you configured it. So there is no rules that this is the option should be. You are free to configure any kind of options. You can go to the official documentation, read what each attribute means, and you can just configure all these things. So we have seen the first graph. So if you understand this particular graph, then everything else is going to be easy. Now, instead of you drawing it on the world map, let's just draw a bar chart, and we're going to draw horizontal orientation. And Plotly, this is the advantage. I'm hovering over, I'm able to interact with the graph, and I'm able to see the details as well. So I'm having the count here, I'm dividing it by slicing it by sector, doing a value counts, and then I'm drawing a bar chart. I'm having a X and Y thing. I'm having horizontal orientation. See, bar chart, you can have it as vertical also, you can have it as horizontal also. I'm specifically mentioning I want horizontal bar charts. Markers is how your data point should look like. So I'm giving how the value should be looking like, how the color scale should be. Color scale, I'm giving it as rainbow. There are multiple different color scales in the official documentations. You can check it out. Then layout, I'm just giving the title. Then once I have the data and the layout, I'm just adding it to the figure object and then plotting the figure object. Now I have this bar chart ready. So what am I able to infer from the bar chart? I'm able to infer that agriculture, food, retail, and services are the categories which receive the highest number of loans. And the categories which receive the lowest number of loans are loan, entertainment, manufacturing, construction. So this is what I'm able to infer from the bar chart. So the advantage of Plotly is it's very interactive. If you just hover over this, you're able to get the details. So now that we have seen the sector-wise distribution of loans, let's also check out the activity-wise distribution of loans. So slice it by activity, do a value counts and do a head on it. And then you will have the X and Y points and do the orientation is H. Then you can burn your marker component. You can give the details. So here the color scale instead of rainbow, I'm giving it as picnic. And then you can give the title in the layout and then add your trace to the data and then add the data and layout to the figure and plot your figure object finally. So it's very interactive. So we have seen the couple of, so what we are able to infer from this farming expenses and agriculture retail are the activities which has the highest number of loans, and the cattle, dairy, food stall have the lowest number of loans. We'll explore a bit more. So now I'm going to explore the other files. So now I'm going to explore the loan amount and the funded amount. What is loan amount and the funded amount is, you might be requesting for a certain loan amount, but the actual amount which got funded is the funded amount. So now we have around 6,71,205 rows loans. Now let's do a simple scatter plot. For this scatter plot, I'm using Matplotlib. So PLT is the alias for Matplotlib. So in Matplotlib, the way you do plotting is, if you want a scatter plot, then you just put the alias is Matplotlib is PLT. That's why it's PLT dot. plt.scatter, and you just give your x and y. In x, what you want to plot, and y, what is the y-axis and x-axis feature names. If you just you'll have to give, that's all. And the figure, you'll create a figure object, and you can govern the figure size here. Plt.figure, you can govern 8x6 should be a figure size. And under scatter, I'm saying the index, that is the 6,71,125. The index is going to be your x-axis, and the loan amount is going to be your y-axis. And then you can go on the other x-axis, x label, y label, and you can also see the loan amount distribution, the title as loan amount distribution. Now you're doing a simple scatter plot using Matplotlib. So Matplotlib is very simple compared to Plotly. So here you just, for platter plot, it is plt.scatter. For histogram, plt.histogram. And for if you want a bar plot, plt.bar. And so it's much more simpler than Plotly. But again, if you see, it's not very interactive. I'm just hovering over this plot. I'm not able to get any interactive visualization here. So let's also do one more scatter plot in this using Matplotlib. Plt.scatter again. The x-axis remains index, and the y-axis is going to be, instead of loan amount, it's going to be the funded amount. So I'm giving the funded amount distribution. So there is one outlier here. So we are going to remove that outlier now. So outlier removal is a very, very important part in your data exploratory data analysis. So because when you have extreme values that might cause inconsistent or inaccurate models, so must find efficient methods to remove the outliers. So what I'm going to do is I'm going to set 99th percentile and the first percentile. So any value which is less than the first percentile, I'm going to set it as the first percentile. Any value which is greater than the 99th percentile, I'm going to set it as the 99th percentile. The figure size is 12,8. So this is the disk plot. So this is the disk plot is the probability density distribution function. So I'm able to see the distribution of loan amount underscore trunk. This is one of the features. This loan amount underscore trunk is the data frame which is created after removing the outlier. So this piece of code, I'm removing the outlier. I'm setting the upper limit and the lower limit. What I'm actually doing here is, if any value is below the upper limit, set that value as the upper limit value. And if any value is above the lower limit, below the lower limit, set that value as the lower limit. And that way, I'm effectively removing the outliers. And so this piece of code does that. And I'm storing the data frame after the outlier removal as Kiva loan underscore DF, this loan amount underscore trunk. This is a this feature contains, this particular column contains the loan amount after the outlier removal. Now I'm going to do the distribution plot on that particular feature. Now I'm using SNS. So SNS is the alias for Seaborn. So I'm using Seaborn to do my distribution plot. Seaborn is similar to Matplotlib. You just have to put the alias name dot disk plot for the density plots and distribution plots. And here again, this is a univariate plot where I'm just giving one feature. I'm seeing the distribution for that particular single feature. And so if you see the feature which I'm going to see, the distribution is Kiva underscore loan underscore DF dot loan amount dot values. This is a feature for which I'm interested to see the distributions. So this is the distribution of that particular feature. See, you can see how the values, it is skewed at one part. And so this is how Seaborn works. So you can try out the other plots in Seaborns as well. You can go to the official documentation, check out the other plots. You can check out the bivariate, some of the bivariate plots offered in Seaborn. Seaborn has got much more better visualization. Again, Seaborn is not very interactive, but Seaborn has got much better visualization components compared to Matplotlib. And you can there are much more advanced styling features and stuff which you can experiment and play with. And now let's get back to visualization of few other features. Now let's go and check out the repayment term. The repayment term is, again, I'm taking Kiva underscore loans DF. I'm taking the term in months and doing a value count on it, which will give me the count of the values for each terms. And I can see which is the most preferred terms by the lenders and the borrowers. So now we have seen scatter plots, we've got seen this plots, we have seen bar graphs and all that. Now let's see the bar graph and the Plotly. So the Plotly bar graph, you will be creating a component using go.bar function. So similar to before, you will create a trace object where you will give the x-axis. Bar graph is a bivariate graph. So you have the x-axis, y-axis, the marker component governs how your annotation point should be, where you can give the color scales, and you can give other attributes which governs the color. Here I'm giving the color scale as picnic. The layout, I'm just giving the title. So now I'm adding the trace component to data, then adding the data and the layout to the figure object, then plotting the plot. So this is the repayment terms and months. Now I'm using Plotly, so you can just see how different Plotly is from Seaborn and Matplotlib, which we saw. I'm just able to hover over, I'm able to get a lot of insights. So the most preferred month is going to be the 14 terms month. People prefer paying the loans in 14 months. And the next preferred thing is the 8 and 14-month terms are the most preferred repayment terms for people. This is what I can see from this graph. Repayment interval in counts. I can use a rainbow and I can do a repayment intervals. I can go for x-axis, y-axis, and I can go a simple bar chart. So there are the most preferred repayment interval is monthly compared to irregular, bullet, and weekly repayment intervals. Then you can also check the lender count. So the lender counters, there are several people who will be coming together to sanction a loan. There could be 500 people coming together to sanction a loan, or 50 people or 100 people. So let's see how many for each loan, how many people are coming together to sanction the loan is captured in this particular column called lender underscore count. Let's do a value count on that particular feature and then do a simple bar graph. And so this is the thing I can hover over. I can see like how many people have come together to sanction each of these loans. And next, we can just, instead of this, we can just zoom out this particular piece of area and we can check it out. We can take the same graph. We can just do a head of 100. We can zoom out that small part and see. When we zoom out, this is the lender count for top 100 people, lender count distribution. We can also see the borrowers' genders. So the most common people to borrow is women with 79.6. Women are high likely to borrow based on the Kiva statistics. And men are only 20.4% of the men are borrowers. And here then using a pie chart. So for pie chart, it is just go.pie. That's it. So now we can check out the country-wise loan amount distribution. So for this, I'm going to use a different kind of a plot called a box plot. So the advantage of box plot is it gives me that five particular features, which is the max value, mean value, the first quartile, the third quartile, and the something called IQR, and all these statistics, I'm able to get using this box plot. So I'm going to plot the box plot for country-wise distribution of loans, loan distribution by company. The way you do a box plot is just use go.box. That's it. Every other thing is going to remain similar. You just have to do go.box, but you're doing it in a for loop where you group by the country, because for each country you want to see the loan distribution. So you're using a for loop and grouping it by country. Then inside that for loop, you're just doing a go.box. And this is what is loan amount distribution by country. So for each of the countries, you can see how the loan amount distribution is. So if you want to do the same thing, but for sector, instead of grouping by country, you can group by sector and then draw a blocks plot. Then you'll be able to see the country loan amount distribution by sector. Yeah, so we've almost come to the end of the session. I think my system notebook, that particular notebook is stuck. So I'll just use this main notebook. So the rest of the parts is very similar, like, the graphs which we have seen already. It's just the bar chart and pie chart and the box plots and the world graphs. So you're plotting the multi-dimensional poverty index for different regions. We have already seen how to draw this world map in the beginning itself. So then the next graph is GDP per capita by country. So we have come to the end of the session. So if there are any questions, so I'll just quickly summarize what we have seen today in today's session. Today's session, we took a real world use case, which is Kiva crowdfunding dataset, which was released 3 years back in Kaggle. And Kiva is an online crowdfunding platform. And what their main objective is, they give loans to the people who are financially poor. So their main task is to identify the poorest of poor people and help them out. And for this purpose, they gave a data set. The competition also had a criteria like you can use external data set, but we just used the data set which was given to us by the host. And we started exploring the 4 CSV files which were given to us, and we used a lot of, we majorly used Plotly, which is an interactive visualization library. And we also, I showed you a couple of graphs in Seaborn and Matplotlib, which is very, very simple, which may not be I just showed univariate plots and Seaborn and Matplotlib. And we just saw different plots like scatter plot, box plot, and how to make an analysis, using these plots. So we've come to the end of this session. So if there are any questions, I'll open up for questions now.
Thank you so much, Usha, for this workshop. So if someone has a question, please don't hesitate to leave it in the chat. Hopefully you get a clear understanding about the use of the Pandas library, about how to create charts in Python. Does anyone have a question? So it would be possible to review later this session on our YouTube channel. I will send you later the link. Okay, so everything is clear. Great. So thank you all for attending. Hope to see you in our upcoming events. Don't forget to join our meetup group, so to be able to be notified about our next meetups. Thank you all for joining, and have a nice day. If you are in Tunisia, you are still on the day. Goodbye all. Thank you, Usha, again.
Yeah, thank you
so
the
much.
organizers of PyLadies Tunis for inviting me. You're doing great job. Keep it up and continue doing great work.
Thank
Wishing
you.
you all the very
Thank
best
you.
for the future meetups. Yeah. Thank you everyone for joining us today. Thank you. Yeah. Bye-bye.
Thank you. Goodbye.